Hello, good morning, viewers. Let us talk about geometric progression series, which is just the sum of geometric progression sequence. In our previous lesson, we have seen that the first term is denoted by a, second term can be obtained by multiplying the first term by the common ratio, which is denoted by r. So we have ar as our second term. Multiply this by r, we have ar to the second power, ar to the third power in that order. And the last term can be obtained by r raised to the power of n minus 1. So series means to add these terms together. So let's see how we can add them. Some of these terms, which is denoted by Sn, is equal to the first term plus the second term plus the third term plus the fourth term plus, in that order, up to the last term. Now let us multiply every term by r. From the left hand side we have r multiplied by Sn. This is equal to a multiplied by r is ar plus ar squared plus ar to the third power plus ar to the fourth power plus, in that order. After the last term, if you multiply that by r, you have to get ar to the n power. Now we have formed two equations, 1 and 2. Now we are going to subtract equation 1 from equation 2. From the left hand side we have rsn minus sn. What I mean here is this minus this, from equation 2 to equation 1. And from the right hand side, if you subtract equation 1 from equation 2, all other terms will vanish except the last term here from equation 2 and the first term here from equation 1, because you can see that ar will cancel ar, this will cancel this, in that order all the middle terms will cancel except the last terms. So we have ar to the n power minus a. Now let us continue simplifying. From this equation right here, you can see the left hand side we have two terms and each contain Sn, so we can factor it out. We have Sn outside and inside we have r minus 1. And to the right hand side, you can see the two terms contain a in common, so we can bring it out. We have a, inside we have r to the n power minus 1. Remember, our main target is to obtain Sn, which is sum of these terms. Therefore, we can divide both sides by r minus 1. So therefore, Sn will be equal to a multiplied by r to the n power minus 1, all divided by r minus 1. Therefore, this formula right here is used to find sum of n terms when r, which is the constant common ratio, is greater than 1. At the same time, if you decide to subtract equation 2 from equation 1, finally you will end up with a formula as n equals a multiplied by 1 minus r to the n power divided by 1 minus r. In this case, our constant common ratio r is going to be less than 1. So if constant common ratio is greater than 1, use this formula, and when r is less than 1, use this formula. So now let me just solve one example and we say bye-bye. All right, this is our question, which reads, find the sum of the first 9 terms of GP, and we are given the sequence here. Let us write the data first. The first term A is given as 3. N is 9 from the question because we are looking for the sum of the first 9 terms. R can be obtained by taking 27 divide by 9. Any term you take divide by the term before it. And 27 divided by 9 is 3. Therefore, the constant common ratio is 3. You can see that R is greater than 1. So we are going to apply this formula right here. Sn, sum of terms, equals A multiplied by R to the n power minus 1 divided by R minus 1. Let's substitute. S9, sum of the first 9 terms, equals A is 3 multiplied by R is also 3 raised to the power of n, which is 9 minus 1. Divide by 3 minus 1. S9 equals 3 multiplied by 3 to the power of 9 is 19,683. 19,683. Then minus 1 divided by 2 because 3 minus 1 is 2. I want to take it step by step. S9 equals 3 multiplied by 19,682 if 1 is subtracted. Divide by 2. Let's multiply 19,682 by 3. This is equal to 59,046. Divide by 2. And finally, S9, sum of the first 9 terms. If you divide this by 2, you're going to obtain 29,523. 29,523. And this is our final answer. And this is also all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.